Hi, everyone. Welcome. Thank you for joining. This is the Oracle Autonomous Database Learning Lounge. I am Marco Sanasibi, a part of the product management team for Autonomous Database. And today we're going to have a very, very cool session. We're going to be talking about basically GraphRAG, right? So, how can GraphRAG actually bring the power of graphs into generative AI, right? So for the agenda today, we're going to have Melly Anamalai. She's a product manager in the team, and she's going to be, explaining, how usually Gen AI LLMs are trained on just available data, but it's not enough, right, for many of the use cases, right? So typically it's outdated, right, or too much general, and that RAG addresses some of that issues, right, allowing you to combine the power of the LLMs with, domain-specific data, right, and private business data. But then GraphRAG can actually enhance that. So we're going to learn more about graphs, right? GraphRAG, and also the power of combining graphs with Gen AI in this session. And we're going to be talking about graph and vector technologies available in the Autonomous Database, right? So before we begin, make sure to ask your questions in the Q&A section of Zoom, okay? We're going to have PMs looking at your questions and answering them. If we're distributing, links to you guys, it's going to be through chat. Okay, so make sure to take a look at chat. And if you want to watch the recording of this session, the slides, and the links that we're going to be talking about today, take a look at that link there in the screen. Okay, and speaking about links, I'm posting this links right now for you in chat. So take a look at the chat. You're going to see these links for our Getting Started page on Autonomous Database, how to reach out to us in social, but also how to ask your question, okay? So we are in Stack Overflow, but also in the Oracle Developers Workspace in Slack. So if you use Slack, you can just click a link there, and you can actually join the Oracle Developers Workspace, look for Oracle Autonomous Database, and you can find us there. So you can ask your questions. You're going to see new sessions coming and things like that. All right. Upcoming sessions next week. We're going to be doing this same session, the GraphRAG, in Spanish on Tuesday. And we're going to have our Migration Part 1 session in Portuguese on Wednesday. Okay. And then after that, the week after, we're going to do our Migration Part 2 session in Spanish in December 3rd. We're planning our December 5th session of that session in Portuguese. So stay tuned for that. All right. All right, guys. So it still looks like the majority here, Melly, are people that are new, right, to some of these technologies. So again, thank you for joining. I really appreciate it. I'm going to stop sharing and let you share your screen and your video. And thank you very much again.
Thank you very much, Marcus, for that poll. That was very helpful. And thanks to everyone for joining. It's great to see the interest in this very hot topic, a very active area of research about bringing the power of graphs to generative AI. And I want to thank our colleague, Edward Cuba from Oracle Labs, who collaborated with us on building some of this content. So let me get started. And given the poll results, I think I will continue on to do a quick overview of what we mean by graph and the graph capabilities in Oracle database. And then I'll walk through GraphRAG, and I'm going to walk through 3 examples, which I hope will give you a sense of the things that you can do when you bring graphs to generative AI in an application. So first, what's a graph data model? And why is it interesting? You might have been hearing about graph databases, graph analytics. So the graph way of representing data is getting quite a lot of interest these days. So basically what happens in a graph is you represent your data as entities, also refers to as nodes, and the connections between them, which represent the relationships between them. So for example, we have like over 300 people attending this webinar. We could have a list of all of us, like in a spreadsheet. That would be a row and column organization. Or we could organize all of us by how we know each other, like have we been to a webinar together? Or in Marcos and I are colleagues, so we have a colleague connection. So you can organize all of us as entities, like also known as nodes in a graph. And the relationships between us is basically who knows whom and how. And that helps you look at your data in a different way and kind of ask different questions of your data more easily, perhaps than you can when you have the rows, when compared to the rows and column organization. So for example, here we can ask the question, is Ethan connected to Amelia? Like when you go, let's say you want to connect to someone on LinkedIn, LinkedIn will usually tell you, you're connected to so-and-so via this person, or you're connected to so-and-so in 3 hops. Or it happened to me recently when I met someone at a conference and I connected with her. We were not directly connected, but we had 100 mutual connections. So we clearly were in the same cohort, we're just not directly connected to each other. So these types of insights are easy to find in your data when you connect your data, when you represent your data as a graph. In other words, graphs are all about making connections in your data explicit. So social networks are a natural example of graphs, but graphs also have uses in many other use cases. Many of our customers are using graphs in many different ways. In manufacturing, graphs can be used to analyze product dependencies, like something like a car has 30,000 parts, and you can understand the impact of changing the design of a particular part, or you can see how you can optimize perhaps your supply chain based on what parts you need to build another part and so on. So all the interconnections between the components to build a product can be nicely represented as a graph. And then we have the financial services industry, which have been the who have been the early adopters of graph technologies, because they are looking to find patterns in how their money moves. So if they represent typically at an abstract level, they represent their bank accounts as nodes in a graph. And then every time there is a cash transfer or a money transfer between 2 accounts, that becomes the relationship between them. So they can look for patterns in the graph and figure out how money is flowing between accounts. For example, if money is moving around in a cycle, maybe there is something going on here maybe there's some kind of money laundering going on. They want to avoid detection or some activity and so on. So finding anomalous patterns is very interesting to financial services institutions. One of our customers recently at Cloud World presented, Garanti Bank from Turkey presented how they're using graphs for this and other use cases. So in Oracle database, a graph is like a view on tables. So when you create a graph from your data stored as tables in the database, you're not moving your data, you're not copying your data. Your data remains where it is, and you're just creating this graph view of this data so that you can analyze your data as a graph. So that has many different advantages. Of course, one is simplicity. You can have the same data either queried as relation tables or queried as a graph. And then all your other business applications can continue their insert, update, and delete operations on underlying tables. And all of that will be instantly reflected in the graph because the graph is just a view on tables. And in 23 AI, this graph object is a native object of Oracle database. So all the advantages you have with disaster recovery, data guard, and flashback, all the other security, all the advantages you have from the Oracle database automatically apply, including concurrency. You can have thousands of users running tens of thousands of queries per second, and it's just like running a query on any database object. So in 23 AI, we have also added syntax to SQL for querying graphs. Like I referred to graph patterns, like a circular pattern that is interesting to find out from a graph. So you need a way to represent this pattern, and you need the syntax for representing this pattern. So we worked along with other vendors. We worked with the standards, SQL Standards Committee to come up with the standards. So in SQL 2023, which was released last year, there is new syntax for specifying patterns. You can see here the lines in red. specify the graph pattern. Like it says A and then square brackets B, it's saying find me all connections between A and B, where A is 934. And in the example here, I'm saying find me all connections between A and B that are 1 to 4 steps long, or in graph language, 1 to 4 hops long. So I'm finding all paths between A and B 1 to 4 steps long. So it makes it really easy to represent the pattern that you're looking for as a graph query. And for comparison, if you were to do this without this new syntax, for example, if you're looking for 1 to 3 hops, your SQL query would look like this. But now that we have this new math syntax, it makes it really easy to write these types of queries. So graphs, because they refer to patterns, are also it's very useful to visualize graphs. For example, find me all accounts that account 934 has transferred money to. Right, so you get a list of accounts that you can visually see. And here, find me all paths between 934 and 387 that are 1 to 4 hops long. You can see all the different paths between these two accounts. So we also have visualization tools in Autonomous Database. We have an integrated notebook where you can run graph queries and visualize the results and so on. So that's the overview of Oracle Graph. And now I'm going to go into one example that I'll be using in a couple of examples. The MovieGraph, and if you have seen some of our other autonomous database sessions, you would have seen us use this data set where we have customers watch movies, and you want to identify based on patterns of which customers watch which movies. You want to make recommendations for specific customers or do other things with your data. So for the purposes of our graph examples, typically we have two relationships in this graph. So we have two entity types or two node types. One is the customer node type, and then there's a movie node type. So, and the customer node types are in green, the movie node types are in blue. And with respect to the relationships or connections between them, we have the connection when a customer has watched a movie. And we also have another connection where groups of customers get together to watch a movie, such as in a watch party. So if these three customers have watched this movie together, that is a connection between them as well. So we have two different types of nodes in this graph and two different types of relationships, also known as edges in this graph. So these three customers are connected together. And again, these two customers are connected together as well. So we have this graph with all of these connections that we'll see how we can create, and then we'll see how we can use that in interesting ways in the generative AI application. So creating this graph is very easy in Autonomous Database, and I'll just show a short demo just to show how easy that is. Like this is Graph Studio in Autonomous Database, and once you log in, you see this homepage where you have the different you have the different options, for example, to see the list of graphs that you have in the database, or you can create a graph. And here I'm specifying the name of the graph. And this is an automated modeling tool that creates a graph after you select your table. So I'm selecting the table, customer, movie, and then the movies the customers watched and the customers they watched with. So I'm taking these 4 tables, and when I click on next, it looks at the primary key information and the foreign key relationships and figures out which are the node tables and which are the edge tables. And I can look, and all the properties that you have in the table, the columns that you have in the table become properties for each node or each edge in the graph. I can add or delete properties from this UI. And then when I'm ready to create the graph, I can go ahead and create the graph. And so and you can see that the graph can be created. So this is a no-code way of creating a graph from your tables. And what has happened here was a view was created, data was not moved, nothing was changed. You just, in the same schema, you're just creating a graph. And you can go and check the graph schema and so on. So now that we've seen how easy it is to create a graph and we've seen what graphs are, let me now get into GraphRAG. I'll just do a very quick RAG recap, what we mean by RAG. So we've all experimented with asking an LLM questions, like maybe the question is, find me a popular movie, and the LLM will tell you, okay, here's the popular movie, by looking at all the information it has access to. But as Marcus was saying earlier, it doesn't always have access to all information. It does not have access to information that is in your database. It does not have access to enterprise data. So for example, if I want to ask a question, find me a popular movie based on a customer's preferences, and this customer is in my database in my enterprise. How do I get the list of customer preferences that I want to feed to the LLM, so the LLM can find me a popular movie based on those preferences? That is what RAG is all about. Finding additional information from your database and using that to enhance the question that you're asking the LLM, giving additional context to the LLM or giving additional information to the LLM. So this typically happens with traditional RAG. Users ask query in a natural language, perhaps, and that is encoded into a vector representation. And that is then matched with the vector representation of data in the database, so that you then retrieve the top K or top 10 or top N results. And then you use that to enhance the customer query, and you send that to the LLM. So if you're looking for a particular customer, you find the preferences for that particular customer from the database, and then tell the LLM, find me a movie that matches these preferences. So that's typically what happens with traditional RAG. So what happens with GraphRAG is, we want to take all the benefits of RAG, and we want to add to it what Graph brings to the table, which is how entities are connected. So how entities are connected just gives you new insights into your data, gives you new information about your data, helps you ask different questions of your data. And we want to have users have the ability to add that information as well to the user context to send to the LLM. So when they're retrieving data from the database to enhance the context, how can they run a graph query in the database and use that information also to enhance the context of the user query? So we'll see 3 different examples kind of to do that. So example 1, I'm going to use a LangChain, because we often get requests from folks, okay, how can we do this in Python? How can we do this with LangChain? And then we're also, then the last 2 examples, I'll be using SQL. So you can do either, all of these examples, you can do either in Python or in SQL. So in this particular example, I want to summarize the movie watching preferences of Adriana, who's a customer, Adriana's friends. So I'm not just looking at Adriana's movie watching preferences, but Adriana's friends. And that's when the graph comes in. So Adriana is connected to various friends based on whether she had watched parties with them and based on what movies she's watched with them and so on. And that is best represented as a graph, as we were seeing earlier in the movie graph. So I want to consult that movie graph to get to understand the movie watching preferences of Adriana's friends. And I want to get the LLM's help in summarizing all of that information for me. So that's the query I'm trying to ask here. How would you describe the movie watching preferences of Adriana's friends? So as I said, I'm using LangChain here, and this is a demo of that. I'm using a Jupyter notebook. That's a standard Jupyter notebook. And I am making a connection to ChatGPT because I'm doing this. I was using a Jupyter notebook, and it's easy for me to do that. And then I'm importing the libraries for connecting to the database, importing the libraries necessary for LangChain, then making a connection to the database, an autonomous database. And then I am creating the cursor object. And then here is the prompt. The question I'm sending to the LLM is, what is the genre of movies based on the summaries? I'm going to give you a summary of summary descriptions of movies. And I want you to tell me what genres these movies are, so I can understand the movie watching preferences of this set of people. So that's the prompt I want to send to the LLM. And I want to enhance this prompt with the results that I'm going to get by asking a graph query on the database. And that's what you see here in this final paragraph. where I have this graph query. So I'm finding movies, I'm finding the friends that Adriana's had watch parties with and the movies that they have watched. And I'm getting the summary description of these movies. And I send that to the, and I chain that, I invoke the chain that I created here to send that to the LLM, send the result to the LLM so that I get a summary back for these movies. So I was able to use the movies that I have in my database, connect that to Adriana's friends network, and then get information about the movies, the types of movies that these friends are interested in watching. So you can, of course, do this in SQL as well. In this case, I just use LangChain to do this as an example to show how this can be done. And my colleague Rahul has a blog post on this. It's either published or will be published very soon on Medium to do exactly this stuff. So the demo was nothing but I just followed the blog post essentially. I just made very minor modifications. So you can see how to do that. And I was running a graph query because graph queries can be run in SQL in the database. The graph query can execute in the database, but obviously you can do this with any SQL query. The same steps would apply. So let's move on to example 2, where we can see how we can combine vector and graph search, and then we'll again send out some information to an LLM. And this is very exciting because you can do all kinds of interesting things when you start combining vector and graph search. So here I'm going to ask a question that is maybe slightly, I'm going to ask a question that Adriana wants to create a watch party. How should she choose a movie? Like what movie should she choose? And which friends should she invite to this party? So what movie should she choose? We'll use vector search for that. And what friends she should invite, we'll use graph search for that because friends and friends networks are nicely represented as a graph. So, and then we'll combine this vector search and graph search in the database, and we'll get the results from this, which will be the movie that Adriana should choose and the friends that she should invite, and then we'll use that to connect to the LLM so the LLM can help her generate an invitation email. So the task would be first is to find a movie that was made in the recent movie with an adventure theme, because that's what Adriana is interested in. And then identify movies in the database that are similar to this movie. And why we're looking at a movie similar to this movie is because we want to find friends who are interested in these other movies that were similar to this movie. So, for example, to identify a movie with an adventure theme, we can run a simple vector distance search on the movies that are stored in the movie table. And we are saying, okay, find me all movies which have an adventure theme, because that's what Adriana wants to work with. And then task 2 is to say, identify movies similar to this movie, because she's identified a movie and then she wants to find movies similar to movies so she can identify the right friends to watch this movie with. So the movie identified is Fall Guy. And now she's saying she's going to go through the movie table and find other movies that are similar based on matching a vectorized representation of the movie summaries. So once she gets these other movies, then we can find out which of those friends watched those movies with her that were similar to the Fall Guy, so that she can invite them to watch this movie. And that's when we have this interesting query where you have a vector search that's telling me, find me movies that are similar to this movie, and find me Adriana's friends who have watched that movie, who will be interested in such a movie. There's a movie similar to the Fall Guy. And these are the folks that would be interesting for Adriana to visit, to invite to a watch party. And once she sends this list of email addresses to an LLM and says, write a compelling email, an LLM will do the rest. So it's a simple matter of writing these queries in the database. All your data is in the database. Really easy to write those queries, combine them, and just send the results out to the LLM and says, send me invitations. And all of this is available as a live lab. I'll just walk through some steps of it. So you can run this yourself. So here is the first query, finding a movie with an adventure theme that was released in 2024. And there are 4 movies that this query found. And now let's say she decides to go with the first movie on the list, which is the Fall Guy. And then she can run the next query, which is find me other movies in the database that are very similar to the Fall Guy, again using vector search. And not surprisingly, the Fall Guy has a vector search of 0, and then you have these other movies that come up with different distances. And now we're just running a few graph queries, and all of this, by the way, I'm running in the Graph Studio Notebook UI. And I'm saying, okay, here's a simple graph query. Find me movies that Adriana has watched. And here's a more complex graph query, which is find me movies that Adriana has watched with friends and the movies that these friends have watched. So here Adriana has watched a movie with Eileen, and they watched the End of Watch together, and she watched a movie with Eileen, they watched The Lion King together, etc. So representing the first query, the movies that Adriana has watched as a graph. Like I said, graphs are very visual. It kind of shows you right away the movie she's watched, and some movies she's watched multiple times. And then here is the second query of friends she's watched movies with and the movies that they have watched. And you can see here that here's a friend she's watched movies with, and then you have the names of the movies. So that's just to show the graph visualization, graph queries in Graph Studio Notebook and Autonomous Database. And here is that final combined query where you're asking the vector search. So for all movies similar to the Fall Guy, find me friends that watch those movies who are in Adriana's network. That is, who have watched movies with Adriana before. And when you run that query, you can then see the result, and that gives you a list of people that Adriana can invite to our watch party. And there are like 2 sets of movies that show up. And when you visualize that, it's always a nice visual that a whole bunch of people have watched the Star Wars movie with her, and a few people have watched the Wonder Woman movie with her. So she's going to go with the folks who watched the Star Wars movie with her. And now she's sending she's sending a prompt to the generative AI service and using DBMS Cloud AI Generate to send the information, send the list of names, and ask for a compelling invitation. So that's example number 2, where you're running your graph query and your vector search in the database, and then sending that to and to the LLM for taking further action. And this is available as a live lab. We had to take it down temporarily. It will be back up momentarily if it's not back up already. Then we come to the example 3, which is, I think, the most interesting part of this session, perhaps. And I'm going to title this The Possibilities with GraphRAG, because at the moment it does require a lot of manual steps. But it gives you an idea of what people are thinking on in terms of how you can use graphs to, let's say, ground what your LLM does, and perhaps reduce hallucinations and so on. So that's the thing we'll try to show here. So going back to our figure here, okay, you're asking query, you want to use graphs. Graphs can be easily created in the database, can be used to enhance your query. And here I'm going to use a story, a Sherlock Holmes story, a detective story, The Adventure of the Blue Carbuncle. And we are going to ask the question of who is the thief in the story. So this is a detective story. So typically, as with any detective story, there's a clear red herring, meaning a clear decoy, a clear kind of wrong answer at the beginning, that is somebody who's wrongly accused of stealing this jewel. And then later on in the story, the real culprit is kind of identified by Sherlock Holmes. So it's a useful story to kind of illustrate where graphs are helpful. So what we do here is to answer the question, who stole the jewel, from a document, you would typically, let's say, chunk the document into these document chunks, and then create a vector representation, that's the embeddings from each of these chunks. And you can store that all in the database. And then you can, when you use RAG, you can say, okay, I'm going to ask the question, who stole the jewel? You create a vector representation of this question, match it with the top K chunks from the database, send those chunks to the LLM, so LLM can read those chunks and then give you the answer. And what is interesting is when you just do top K chunks, the first answer that the LLM finds is the fact that that's the wrong answer. This was the red herring in the story, which says John Horner, so-and-so, was accused of stealing this jewel. Because that's the thing that is clearly explicit in the text, that so-and-so stole this jewel. And the real culprit, if you look at it, interesting, the real thief is someone else, is someone called Ryder. And nowhere in the text does it actually say James Ryder stole the jewel, but it's implied in 100 different ways. So a human being reading this can easily figure out all the implications and the logical connections. But it never explicitly says really or where that James Ryder stole the jewel, whereas it says John Horner stole the jewel. So how can we now use all of these facts in the rest of the story to identify the real culprit? So this is where graphs have the power of representing information in a nice way, representing relationships in a compact way, and also in this case, for example, connect across chunks. So vector search will just match each individual document chunk. Whereas with a graph, you can kind of go across chunks, you can find other related entities, and so on. And that's what makes graphs really interesting in this case. And we'll see some code snippets of how this can be done. So what we do here is, so we to create the graph. So now we saw how we created the vector representation of the document chunks. How do you create the graph? We send the chunks to the generative AI service and ask it to extract nodes and relationships and say that, okay, give me this nodes and relationship that I'm now going to put in the database. I'm going to create a graph, and then I'm going to run a graph query and combine that with my vector search so that I can send the right chunks to the LLM. Because what happened with the plain vector search was the initial chunks that were sent to the LLM were not the right chunks. They were actually the ones which had the wrong answer. So you want to identify the right chunks, and the graphs can help you identify the right chunks to send to the LLM. And so that, for example, the graph could have something like this. The location of the jewel robbery was in Hotel Cosmopolitan. You have robbery and Hotel Cosmopolitan as two entities, the location of the relationship between them. Ryder is employed at the Hotel Cosmopolitan, and so on. You have these pieces of information that you want to put together to identify the right chunks to send. So let me now walk through some code snippets. And once again, these are possibilities. So I'm first creating a table that to store the chunks, and I'm using our DBMS vector APIs to chunk the document, chunk the story into different chunks and store that in a table. And then I'm going to use the DBMS Cloud AI API with a prompt to send the chunks to a generative AI service to get back the nodes and relationships. So for example, if it says, and the prompting says things like, Melly works for Oracle, means Melly is an entity, Oracle is an entity, works for is a relationship. So in the prompt, we give a few examples, and using those examples, we get back a set of results, and we get back some of that as JSON data. So we do some parsing to extract the individual nodes and entities, and then we have this table which contains the relationships and entities extracted from this document. So we can see here, for example, you have Holmes is an entity who's interacted with, that's the relationship, interacted with Peterson. And then you have other things like James Ryder works for the Hotel Cosmopolitan, and James Ryder has showed something to this countess who owned the jewel incidentally. And now that I have all of these entities and relationships, I can create a graph from this. I can say, okay, I have the node tables with the entities, I have the relationships table, and I'm going to create a graph from this. And after I create a graph, now I need to see how I can combine the vector with the graph. So I need to get a starting point into the graph, like where do I start this graph search? So I ask who stole the jewel. I use that to find the right relationship that I have to start, where I can start my graph search on. So here we say who stole the jewel matches with Hotel Cosmopolitan is the location of the jewel robbery. Of course, this will depend on what model you're using. So now let me go to Graph Studio and run some of these graph queries. And this is just a simple, let me find all entities which are connected. And this is kind of a graph representation of that story, like the different entities, the relationships. So you can just think of that as a graph relationship. This is Holmes' highly connected node because Sherlock Holmes appears repeatedly in the story. Now I'm going to use the jewel robbery and Hotel Cosmopolitan, and then I'm going to extend that. So jewel robbery is connected to Hotel Cosmopolitan. I want to see what other entities are connected. And that's what I do by running this query. And when I do that, I get something like this. I say, okay, the Hotel Cosmopolitan was connected to the Countess who was staying there. That's who the jewel belonged to. And it's also connected to James Ryder. So then maybe I want to look more closely at James Ryder. So I'm going to see that James Ryder is connected to Hotel Cosmopolitan, and I'm going to extend that connection using that graph clause there. I'm going to say, find me who else are connected to this particular relationship. And then I get something quite interesting. I get all kinds of things connected to James Ryder. So these are now point me to document chunks I can now send to the LLM. So rather than just doing a vector search, I can now use a graph search to identify specific document chunks related to the robbery in question, and then send that over to the LLM so that it can tell me who the thief is. And a couple of other interesting things here. If you do a graph search based on James Ryder, like find me all entities connected to James Ryder, you find a lot of different entities here connected to James Ryder. But if you look at find me all entities connected to John Horner, who was the wrongly accused one, you only find a few connections. So that's the interesting thing. But in an English sentence, it is very explicit that John Horner was accused of stealing this jewel. But then later on in the story, he doesn't really appear. It's James Ryder who appears more frequently. So that's how the graph is able to capture all of that information and identify additional chunks that you can use to identify the right answer. And then finally, the blue carbuncle, which is the key star of the story. I just wanted to see all the entities connected to the blue carbuncle. And that is connected to Sherlock Holmes. The detective was connected to a whole bunch of things in the story. So once again, this is a visual representation of the story. So I hope this gives you an idea of the things that graphs can do and all kinds of ideas. I hope it starts creating lots of ideas on how graphs can kind of help in search and searching documents. So GraphRAG is an active topic of research. I don't want to trivialize the problems that are there. For instance, how do you extract these relationships from data? We had to do some prompting to get the relationships by using an LLM. And how do you do entity resolution of the extracted entities? Like Holmes and Sherlock Holmes, they are one and the same thing. James Ryder, same as Jim Ryder. These are not trivial problems, and people are working on how do you connect them, because you want to make them all one node in the graph. But the basic point is graphs are really good at capturing complex interactions, and hence the name knowledge graphs. Right? People like to use the word knowledge graph. It just talks about how relationships and interactions in the world can be captured, and that can be used to enhance search, enhance queries we ask of our LLMs, and so on. We're also exploring how we can use Select AI to generate graph queries. You will notice that I was actually running graph queries. I wasn't using Select AI or natural language queries because the SQL PGQ syntax is very new. We don't yet have enough, the LLMs are not trained enough on that to actually generate the graph queries, but that's something we are working on as well. So key takeaways, I think graphs provide new insights because of the way they capture relationships and data and make those relationships explicit. And in Oracle Database 23 AI, we have new SQL syntax to make it really easy to write queries and query data based on these connections. And you saw that in Autonomous Database, we have Graph Studio, makes it really easy to create a graph. And you can see the visualizations that I was showing, they were all from Graph Studio and Autonomous Database. And again, to reiterate that graphs really can add value to AI because they can help you bring grounding. So what I'm particularly excited about is enterprises might have knowledge graphs that represent their business. Like in this example, we were trying to extract this graph relationships from the document itself. But you can easily think of a scenario where a knowledge graph captures information about a business. And we already see this, RDF knowledge graph customers, manufacturing customers have specifications that are nicely captured in a knowledge graph. And if you can use that in collaboration with your LLM queries, that will help you ground the results that you get from a Gen AI service based on the knowledge graphs that represent data in your enterprise. So I said a lot of these things are available as either blogs or live labs. We have lots of resources. And I also, the final thing, the example that I did with Sherlock Holmes that we are planning on publishing as a blog that is not out yet. We will do some more work on that with different models, and then we'll publish that. But my intent was here to give you an idea of how of the different kinds of things that are possible. So with that, thank you, and I think we have some time for questions.
Excellent. Thank you very much, Melly. I know that Rahul probably has some cramps in his fingers since he's been answering so many questions and typing as fast as he can there. We have a few open questions, so Melly, if you don't mind opening the Q&A.
Yeah.
And we can review them together. Just the last ones here.
So should I just go in order? I'll just go in order. Okay.
Yeah, sure.
How can we generate the relationships and the chunk data? So that is a quick question. So that's a good question, right? So in this example, we just send the chunks of data to our OCI generative AI service. And we gave it some prompting. We said, okay, Melly works for Oracle. That means you have to extract Melly and Oracle as entities and works for as a relationship. So we gave some prompts and we said, okay, now we have this piece of text, this chunk, give me the entities and relationships from it. We are working with other like the financial services business unit to tailor some of this for their financial documents. So there's lots of work underway, and this is where we're actively collaborating with Oracle Labs on making this process simpler. The second question is graph matching done with the same text chunks of vector embedding to generate a relationship? What I was doing was we created the entities and relationships from the text chunks, and the text chunk, each chunk had an ID, and each ID was connected to an embedding because we had a vector embedding for each chunk. So when you do the graph match, you can send those vectors to the LLM to get the right answer. So in other words, graph matching is done with the same text chunks, I guess. Yes, in this case, we did that. But then if you're able to do entity resolution with these different graph snippets, you can kind of really get a graph that kind of represents the whole document. How can we augment LLM with a graph schema? What entity? So I think this is the interesting thing. It depends on what you're looking for. Like in this particular case, I started with the question, who stole the jewel? And I used that to get an entry point into the graph to find the entities relevant in the graph. And from those entities relevant in the graph, I connected to the different chunks and then used that. Will this presentation video be shared? Yes. Thanks to Marcos. Yes. What is the upgrade path from 19i to 23ai? I see that Rahul is typing an answer. I'll just add to that perhaps. So graphs are supported in 19c. But at that time, the SQL syntax was not part of the standard. So we supported something called PGQL, a property graph query language. So you can start using graphs today with the PGQL language. And we have made the PGQL syntax to be identical to the SQL syntax in 23ai. So you should be able to write your application with the PGQL queries and then easily move the application to 23ai. And we actually have a blog post on this comparing PGQL with SQL and so on. So our goal is to make it as easy as possible for people to move. I will also say that PGQL will continue to be supported in 23ai. So we're using graphs in 19c and you want to move to 23ai, everything will work. You don't have to move to the SQL syntax. But folks who are getting started, we really recommend the SQL syntax. Graph, going back to embeddings for a generation, why is that important? I'm trying to understand the question here. Oh, going back to embedding. So so I had to create the graph from, in this case, I was creating a graph from the document. I mean, that doesn't always have to be the case, but I was creating the graph from the document. So I was just using the chunks because I already had the chunks. I was sending the chunks out to create the graph. If you're using a different graph, like for example, if you're trying to do this and you had somebody with the police had a database of folks with a record or something, you already have this information outside in a database. You already have, that can be fed to this. Or for example, maybe you did not know that James Ryder worked for the Hotel Cosmopolitan. That might come from the hotel's HR database. That could be represented as a graph and then sent to this. I mean, in this case, I was just using the document itself to generate the entities and relationships because I was just trying to show how search can be done. How is the cross-reference between chunks done? So that's where when you have, let's say, Sherlock Holmes represented in two different chunks, you can say that these are the same entity and you can combine them. And it becomes one node in the graph. And then the graph can say, okay, Sherlock Holmes is connected to all of these different entities. So that's where the cross-ref, because you identified the key entities, you can kind of connect across chunks that way. Does the system support importing ontologies and projecting onto a knowledge graph? Can you edit the imported graph? Seeing that in a demo would be useful. Yes, Autonomous Database supports ontologies if you're using the RDF standards that typically are used for representing ontologies. And can you edit the imported graph? That's a good question. Can you visually edit? You can do some things visually, or you can do some things programmatically. That's actually a good question. Maybe we'll think of that for a follow-up session. Like how can you, when you're importing a graph from elsewhere, if you want to massage it and change it, how can you do that? So thank you for that. Do you experiment with graph generated from source code, which can find some pattern in the code or known mistakes using Graph+Vector Search with Gen AI? Will this be a useful case to solve? So we do have folks using graphs when they're moving from, let's say, an older system to a newer system, like old antiquated code that nobody really maybe understands. They use graphs to represent how the source code is laid out, like which functions call which functions, how does data flow, and so on. In fact, internally, also in Oracle, the developers use a tool to understand how different functions are connected to each other using a graph. So there's a lot of, I think there's a lot of use when you use, lots of interesting things you can do when you use graphs to represent complex body of source code. And can you find patterns? Definitely, I think that will be a good use case to explore as well. Will graph queries be used instead of SQL when Select AI creates queries, or is there a different setting we need to ensure that Select AI also uses the graph query? So today, Select AI will not generate the graph query. So graph queries is just using SQL, so you would just write the queries like I was showing in the demo, but we are planning to, in the future, have Select AI create queries that work with graph. There's no different setting that is needed. Right now, to write queries, you just use SQL to write a query. And just be mindful that if you're using Select AI, it will not be using a graph query today. The next question for generation, we had to go back to embeddings for generation. Why not the graph directly? For generation of the, maybe you're asking about the final answer. I mean, in this case, I wanted to send the document chunks to the LLM, so the LLM can look at the chunks and then give me the answer. So I was going back to this embedding, so I can match the embeddings and then send those, basically find the right document chunks to send back to the LLM. Not necessarily embedding, but find the right document chunks to send back to the LLM, because only the graph does not have enough information for the LLM. The LLM needs the document chunks associated with those entities in the graph. Does this approach only work if you have some kind of a relationship between data? Can this serve any question from a document? All data has relationships. Right? All data has some kind of relationship or other. So the question is modeling your data so that you're making that relation explicit, highlighting the relationship, and then using it effectively. Oh, can this serve any question from a document? We think so, because especially as the document grows very large, or you're having a whole repository of documents, and you want to comb through all of that. I mean, identifying the different entities and how they're related to each other becomes very interesting. Like if you're looking at the Sherlock Holmes stories and all the archive of stories that he has, the Sherlock Holmes will be a very key node, right? He'll be connected to a lot of things. Watson will be connected to a lot of things, and it's useful to get those kinds of insights, and maybe you can find patterns from the plot and so on. So I would say you can use it in many documents as long as you're able to, you identify the relationship and it's connected to the question you want to ask. Where can I get a recording for today's meeting? I'm sure Marcos will be sharing that. Can you please tell us the tool used to analyze the source code? I guess we have some partners doing that. I think last year's Cloud World, there was a hands-on lab on this. And we can, I don't remember whether we have a blog post on this or not, but there are some partners working on that. Whether it's on the roadmap for the database, I mean, GraphRAG in general, like some things we can do today. We have the live lab and the blogs, like for connecting a graph query to a generative AI service. And some of the other things are using graphs for better search and reducing hallucinations. We're exploring what will be useful for our developers and customers. What advantages do you see with our graph query language versus open source graph query languages? The frontier will likely be aimed at more standard. So this is a standard, right? I mean, the SQL syntax that we have is the standard. And we believe it is very important to have a standard in SQL because it makes graph queries accessible to a lot of developers. Anybody who knows SQL can use graph queries, can write graph queries. They don't have to learn a new language, and existing tools can use this. Like I was just using database actions for some of this demo. You can use SQL Developer. You can use any tool that runs SQL can essentially run graph queries. So that is why we work with the SQL Standards Committee to enhance that rather than have a customized special language for graphs.
Excellent. Thank you very much, Melly. I think that was great. I think that's most of the questions we had. I think it's everything. Marty's still typing an answer there. So guys, thank you again very much for attending the session today. I am sharing with you again all the links for Autonomous Database in chat, okay? And again, if you still have questions, make sure to type them in Q&A. We're still looking at them, and we'll keep an eye on those questions for a few more minutes. All right? And then final thoughts. Many people asked about the recordings and slides and things like that. So they are going to be available on the main site. So that's the oracle.com/go-to/ADB Learning Lounge, like you see here. And you're going to see links there. You're going to see the upcoming sessions and also the replays, right? The recordings. Okay. What else? I think that's it for now. Again, thank you very much, Melly. Thank you for joining. It was a great session. I really appreciate it. I think a lot of people learned a lot. That was that was the final tally here. A lot of people learned a lot. That's a majority. And then I will leave us out with some music. But again, we're still listening to your questions. So if you still have questions, you still have time to type them. We are going to get back to you either by replying in the session right now or by email if we are unable to. Okay? Again, thank you. Thank you very much, Melly.
Thank you, everyone. Thank you, Marcos.
Thank you. Appreciate it. Take care. Thank you.